I didn't understand them. And so I spent this evening reading about them and just trying to understand, why the Rust compiler was complaining and what it was actually trying to do. Ultimately, if we look at, I've kind of rewritten the code, but if we look at add, you'll see like I was including this vector operands in the instruction, which is fine, except I think right somewhere around here in the processor, get an item out of this instruction object, right? Out of this vector in this instruction object. And so doing that, it requires, depending on how I got that, it would become a borrow on the parent object, which would be the instruction type. And then I started trying to set things elsewhere in the struct. And since it was borrowed here as immutable, because all I did was self.get instruction stack, that's an immutable borrow right there. Never mind that I'm actually getting something underneath it. This is a mutable borrow, an immutable borrow, and then you get down here and then you try to modify. So a mutable borrow, this parent struct, and you can't do that. So I had to be quite dramatic going about doing this. So, and that's the thing with like learning new languages, is that if you have to recognize that, or I had to recognize that it was going nowhere. So I had to change how I was just approaching the problem completely. So now, still have a processor, so this proc, and a processor has an IP, an accumulator, an instructions vector, a state, and a hash map that's just basically a count of how many times each process has been run. And then cleaning out all the other stuff. Okay, so then when you run, it sets the process states are running and then just loops through the execute, right? And so in this situation, I get a count from the count hash map and increment it, and then do a match on the count. And if the count is 1, then I go through and actually execute. And if it's anything else, which means it's over 1, I stop the machine, and then I can pull the accumulator. So whenever it does execute the instruction, it matches. Ooh, that's a match that needs to go. Hold on. I think this actually goes like that. Right. Oh, actually, it's like that. Okay. And so in this situation, it gets the instructions, or gets the instruction pointer, and then does basically a switch. If it's a no op, just increment the encounter. If it's operation, ACC, then accumulate the counter, and then increment or accumulate the accumulator, and then set the counter. And if it's jump, change the modify the instruction pointer. Super easy, eh? So one of the things that's also changed is that there's this operation ACC, operation JMP. I've used structs for the operations. And so the structs, you'll see that the operations are actually just quite simple. This is no op with no parameters, ACC with one parameter, jump with one parameter. Now, the instruction no longer has a nested list under it or a vector. And so that just means everything here, since these are not on the heap, they're on the stack. Which makes it super easy to deal with them. So you see right here, whenever I parse or create, and basically give it the string of text. This is a new thing. I'm using slices instead of the string. Split it on I. Top is the rest. Right? Super easy. So with that in mind, we run it. Oh, we gotta save it. Error 1331, which certainly sounds like leet. So we're gonna see if that's it. Hey, all right, we did get it. That's good. Okay, after some careful analysis, you believe that exactly one instruction is corrupted. Somewhere, either a jump is supposed to be a no-op, or a no-op is supposed to be a jump. No HC instructions were harmed in the corruption. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly one jump or no-op, you can repair the boot code and make it terminate correctly. For example, consider the same program from above. If you change the first instruction from no-op to jump, it would create a single instruction infinite loop. If you change almost jump instructions, okay, we're going to need a reset of that. That's going to take a mute. So that means that self.ip equals 0. Oh, what I got some stuff. My channel. Oh, achievement. And loot. Okay. Well, that's interesting. I think I'm the only viewer. Anyways, self.ip equals 0. Self.accumulator equals 0. So that resets the state of the machine. And then I would self.exec count equals hash map new. That's just gonna that and self.state process state. Yep. So that resets. And now how long does it take to execute our loop? 1 millisecond. So So now we're saying okay, and we want this to return a process state. Okay, and so that means that run now gives me okay. If you change, so after some careful now, you believe that one either jump is supposed to be a no op or no op is supposed to be a jump. Okay. Okay, I'm saying there's a flip index. Okay, and flip index. Hey, do you already solve this iteratively, or are you doing it? Are you doing it recursively? What do you mean iteratively? Like trying to solve it functionally? No, I'm not. No, I'm not doing it functionally because it's gonna. If it's Eric's puzzles, it's gonna build. Yeah, for the loops. Yeah. So the loops, I use iterators. So, using maps and things like that. But solving it recursively, yeah, I mean it runs and then it executes. And the loop, this is pretty much the execution loop. I'm sure there's a functional way to solve this. I think I'm ready to wield Rust in a functional way. I'm getting close. All right. So, with that being said, index, and then I'll run it. And then I'll say function flip next attribute self. Then I will get an iterator on the instructions. But get If flip index is greater than 0, okay, there we go. Flip index is greater than 0, and get the flip index. And then they want to parse it here, which is this. Okay, hold on. This is where I got to do Rust vector set element. Okay, so I think we'll do a match. We want the flip index. And if it's a no op, I don't actually need to do anything in that case. Care. Nope. Okay. I don't know how I feel about this, but let's see. Okay, so if it's a no op, self.instructions dot is it going to be set? Rust set value vector. Instructions flip index. Oh, I see. Oh, that's stupid. Okay, well, then we can't do this. Okay, I see. It has to. You have to give it an op. Otherwise, you can't flip it. There we go. Okay, so I think that flips it. Pretty sure that's going to flip it. Okay. You turn that to a no op. Okay, so that means if flip index is greater than 0, then flip whatever we flipped previously back. Right? And then you want oh, Mr. Speed kills. Oh, you got me thinking about how to do this in a different way. Okay, yeah, that's interesting. So what if flip I, new size. Instructions like get. Okay, so there we go. So there we yeah, and then I can flip that. Okay. I'm gonna flip it. Okay, so then let's just do this again. Let's just leave that one alone. Okay, now let's try this. Let's say instructions.iter.map, and then I want to map I to E. I want. And I want to map. I'm not sure I need. I don't think I need that. I think I just need that. And for each one, I want to map CPU reset. Okay, obviously, yeah. I'm thinking just similar. I think. Oh, I don't know about backtracing. So if I flip it, and I map the flip function on each item, and it's only going to flip the jumps, and then it's going to execute and record that. And then if I have map rust map index, it might even. What is it actually asking? What is the value of the accumulator at the program terminate? Okay, CPU.reset, CPU.flip. So we're going to go execute it. It stores a tuple. It stores CPU dot ret and CPU dot ACC. Yeah. Well, let's try this. Filter. Yeah, okay. So that process state stopped. To reset the CPU, flips I, runs it, flips I back, and if it was stopped, then it keeps that one in. Right? So now I should just have ones that stop. No, I don't want to do that. I don't want to do that because if it stopped, I need the accumulator value after it ran. So I would say I need to map, and I would say return ret. Okay. That's totally not gonna work. Yeah, it's funny. Obviously, that's wrong. Oh, I actually don't need to flip in. I don't need this flip index at all. Here I added that. Expected zero fields, got one. Okay, well, that's because there's an I-32 and no op now. There we go. Found a reference to an I-32. Okay, now this is a dereferencing the borrow. That's a borrow, so yeah, just I think we're going to dereference that because it just needs to be the value. Okay, flip index is still somewhere around here in reset, probably. Yep. Okay, let's try that. Uh, oh. expected. Ooh, this is how you do maps and Rust. Rust map. Let's see. What am I doing wrong? Oh, that's right. Index. Oh yeah, you need the enumerate. See, I was right. I did need the enumerate. Okay, we're down to 2. Instructions.get. $94. What are we doing here? 94. Self. Okay, almost there. I don't know how that worked ever. Oh, maybe I can just do this. Oh. Oh, because I moved it. Try that. It's not going to like me doing this. It needs to be within pub function find flip. Okay. It's not gonna like this. It's not gonna like this at all. It's gonna freak out. It's almost definitely gonna freak out on that. There we go. I'll do that. Now, it's because of this borrowing. It freaks out the function. So I think I need just an iterator for about that? Iterate through each one. Go iterate through each one, reset it, flip I, run, flip I, if okay, let's try that. Oops, adjust. Ooh, this is okay. It's not the prettiest thing. Okay, first mutable borrow occurs here. Okay, so it doesn't like that. What if it doesn't return a string? You reckon that would work? Okay, let's try that. What? It's not a borrow. Yeah, that's pretty much what I'm doing. Yeah, that's it. Flipping one, testing, and then flipping another one. But I can't figure out the borrowing again. Mutable borrow, later used here. Cannot borrow. What if I do this? Ooh. Okay, what is the accumulator as the program terminates? uh, okay. Well, what? Now I just figure out how to get that value. I snuck a print line in there so that anytime it stopped, it would just print out what the accumulator is. Because stopped is different than it hit a loop, which is good. So I can just do flip, run, flip, and that flips it back. But how do I get it to return that? Let's see. Let's see, Rust. Okay, so you gotta do break. Oh, wait a minute. Okay. So did that work? I wonder if that works. I wonder if I can do that. I don't need that because it will do that automatically. What about that? Can I just explicitly call return like that? Oh. I don't want that. I want the value at. There we go. Okay. Now it prints the. Okay. That's what it needs to be. Okay. Well, that's good. I've solved that problem. Just flipping and then moving on. Okay. Well, that's good. But I want to get rid of that print. Where is that print at? There it is. Okay, so we got a processor. The processor has an instruction set, and then our instructions are done with operations. And this is the parsing function. So you really have the parsing and then the execution for additional instructions. What'll get wonky is when we start adding different kinds of parameters. I'm going to have to add functions for that. So let's see what day 8 is. I mean, day 9 now. With your neighbor happily enjoying their video game, you turn your attention. Speaking video game, let's see how far Cyberpunk is. Uh-oh, I think Cyberpunk's ready. Ooh, no. Cyberpunk is at 80%. So we just need 1 more gigabyte of download. All right, we're back. With your neighbor happily enjoying their video game, you turn your attention to an open port. Though the port is non-standard, you manage to connect to it through the clever use of several paper clips. Upon connection, the port outputs a series of numbers, which is your puzzle input. The data appears to be encrypted with the exchange system, which is convenient for you, is an old cipher, an important weakness. Xmas starts by transmitting a preamble of 25 numbers, and after that, each number you receive should be the sum of any 2 of the 25 immediate previous numbers. Okay? The 2 numbers will have different values, and there might be more than one such pair. Okay, so after that, the number you receive should be a sum of any 2 of the 25 immediately previous numbers. The 2 numbers will have different values, and there might be more than one pair. For example, suppose your preamble consists of the numbers 1 through 25 in a random order. To be valid, the next number must be the sum of 2 of those numbers. Oh, this is okay. 26 would be a valid next numbers. It could be 1 plus 25 or 2 plus 24. 49 would be a valid number. It's a sum of 24 and 25. 100 would not be valid. No 2 of the previous 25 numbers sum to 100. 50 would not be, although 25 appears in the previous 25 numbers, Okay, suppose the 26 number is 45, and the first number, no longer an option, as it is more than 25 numbers ago, was 20. Now, for the next number to be valid, there needs to be some pair among the numbers 1 through 19, 21 through 25, or 45 that add up to it. Okay, but there was no 20. Oh, I see. In this example, after the 5-number preamble, almost every number is the sum of the two previous 5 numbers. The only number that doesn't follow this rule is 127. First step of attacking the weakness in the Xmas data is to find the first number in the list after the preamble, which is not the sum of 2 of the 25 numbers before it. What is the first number that does not have this property? Okay. Just missed that tip. Oh, we were going to try out Sea Lion. Let's see how Sea Lion does. I'm going to move to Sea Lion here and see if we can get Rust installed on it. Sure, it's taking a long time. Sea Lion, do not send anonymous statistics. Do not import settings. Activate Sea Lion. Okay, let's try this. Oh, no, that's not what I want. Okay. Okay, I think I did it. So that will be it. Welcome to Sea Lion. Okay. Plugins. Install Rust. There we go. Yes, install Tonal. That's a great idea. Restart the IDE. It's super interesting to watch me install different IDE. That's one. So I started off in Vim, and Vim, was nice, but I feel like it slowed me down because, yeah, I need the hints. I need to be able to find things. So hopefully, I hear Sea Lion is good for Rust. So we'll see. Inputs. So I think we're going to have a new input. New file. This is going to be day9-1.txt. And we just need the input here. Okay, weird. Okay. Yeah, do that. Oh, the numbers get big. That's, I see. So there's day9.text. Let's see our day9. 9. Yeah, so about the VS Code, I started off in VS Code, but this is an M1 Mac, and VS Code and the M1 and Rust are all, they're not friends with one another. And so VS Code would crash. And I think it's because VS Code is being ran under the x86 emulation. And then it's trying to execute the Rust, which is compiling for ARM, and it just doesn't like it. So, yeah, Rust is super fast. The memory safety, though, and memory safety requires a change in how you think about things. It's yeah. There's a lot here that's changing how. I mean, if you're like used to a garbage collector, then the garbage collector does a lot of stuff for you. And whenever you don't have the garbage collector, at least I don't know about you, but me, it changes how I structure things. Well, yeah, I structure things in really lazy ways because of the garbage collector. Now that there's no garbage collector, I really have to think about memory. Okay, so let lines equal. Ooh, that's nice. Telling me what to do. Lines from. Okay, there we go. Ooh, and look at its inferring types. That's super nice. There we go. That's super nice. That'll get me my lines. And then I think we want a function. And you really want well, no, don't do it that way. Do lines dot iter dot map. And I would even do enumerate. Ah, that's great. Nice to meet you, Alan. Oh, awesome. I'm in New Zealand, Alan. I'm on the other side of the planet. But yeah, I am from Texas. Originally. Nice to meet you, Alan. And thank you for watching. Don't forget to follow. I think that's what you're supposed to do when you're streaming. I'm new to the streaming as well. All right, here we go. And then, okay, now this is a pair here. If I is less than 25, then yeah, that's fine. Oh yeah, I got recruited to live here, so I moved. Yeah, it was a couple of years ago. Yeah, I won some sort of contest, and they like gave me a free trip, and I came over and interviewed, and then they gave me a nice job, not free job, and yeah, I relocated. So yeah, very very cool experience thus far. Although earthquakes take some getting used to. Much nicer here. Yeah, this is a move that's paid quite a few dividends in the last year, in terms of the situation out there. But it's just tragic being so far from family and stuff, and seeing all the things that are happening, and it's like, what is going on? Yeah, I'm not a citizen yet. Still got a few more years for that. Oh, let's see. Okay. So I want to enumerate on these. Yeah, I don't have any. I mean, I would love to say, but that it depends on a lot of things. You got family, and pray to God that they stay healthy, and nothing happens that means you need to go back home. But if the world calls, then I gotta go. Oh, oh yeah, yeah. The long travel is long. Yeah, but once you get here, it's short distances everywhere. So there's anything longer than 1 hour. Maybe 2 hours to the South Island. It's a beautiful place. You should totally come. It's very cool. People are awesome. People are the best. The people are super, super cool. And super laid back. Okay. So I got my lines. That's good to hear. Yeah. I don't know if anybody in my family's gotten it yet, or if they're going to, or if they're not going to, which is part of the anxiety. That being said, I don't know about the rest of my larger family because I haven't really talked to them. But if they did get it, I think they've all recovered, which is good. Super happy about that. 13 days. It's a long time to be sick. Okay, I want buffer function is valid. And then I just need to iterate through the previous 25 and find a pair. I can't sort a slice, can I? Rust, sort, slice. How do I partially sort a vector slice? The standard library does not offer such functionality. I think I need like some sort of binary tree going on here. All right, see ya. Thank you for watching. Don't forget to follow or subscribe. I think I got a total of 2 followers. Thanks for watching, though. Thanks for chatting. I think you're one of the first people I've ever chatted with on this. All right. So enumerate from lines from file. Lines.iter.enumerate. I really want to check this real quick. Insert disk 2. Okay, I'm going to insert disk 2. Okay, disk 2 is in. So what does that mean? It's still installing. Oh, it's downloaded. Oh, I think it's almost there. All right. Function. Okay, so It's 25 times 25 sums. So 625 sums. Okay, what is the actual value that I'm looking for? Okay. Oh, I need to close the windows. Alexa, turn the lights on.
Okay.
Okay. So, I'm using C line now. Wait, what was my for loop look like in the previous day? For I in. For there we go. There we go. A slice. If is valid. And then I want a slice of numbers. I minus 25. Okay, wait a minute. It wants, what does it want? Okay, we're out of that. It wants the only number that doesn't follow the rule. So it wants okay, I think that does it. Okay, that does that. Okay, I think that's it. I think this is a number that's a vec of U64s. There we go. 617 it says. Let's see if I still got it. 617. That's not the right answer. I think it's I think that's what it is. Let's try that again. This number. Hey, got it. The final step in breaking the Xmas encryption relies on the invalid number you just found. You must find a continuous set of at least two numbers in your list which sum to the invalid number from step one. Okay, so this is similar. Okay, so I would say, for each one. Okay. For higher numbers. U64. Okay, let mutable sum U64. So in this one, sum equals numbers I. Okay, let's try that. I don't want a slice of that, so I just do this. Try that. Let's see. Okay. Oh, I see. Hello? Yep. Oh, there we go. There we go. So we got a number. Hey, we got it. All right. Now we're on day 10. We're all caught up. Okay, so Oh, that's cool. Also, my Twitch things, they do come through. Each of your voltage adapters is rated for the specific output voltage. Any given adapter can take 1, 2, or 3 jolts lower than its rating and still produce its rated output jolt. In addition, your device has a built-in voltage adapter rated for 3 jolts higher than the highest rated adapter in your bag. If your adapters were 3, 9, and 6, your device's built-in adapter would be rated for 12. Treating the charging outlet near your seat as having effective voltage of 0. Since you have time to kill, you might as well test all your adapters. Wouldn't want to get... If you use every adapter in your bag at once, what is the distribution of voltage differences between the charging outlet, the adapters, and your device? For example, with these adapters, your device's built-in voltage adapter would be rated for 1922 volts, 3 higher than the highest. Because adapters can only connect to a source 1 to 3 volts lower than its rating, in order to use every adapter, you need to choose them like this. The charging outlet has effective 0, so the adapters that connect to it directly would have a voltage rating of 1, 2, or 3. Of these, only one you have is an adapter rated 1 jolt. For a 1 jolt rated adapter, the only choice is your 4 jolt rated adapter. From 4, the adapter is 5, rated 5, 6, 7 are valid choices. However, in order to not skip any adapters, you have to pick up the adapter rated 5 jolts. Okay. I think I get this one. So, new file day 10-1.txt. Okay. That's super stupid because, well, I mean, it's not stupid, but okay, there's A10. A10 in. Okay. Okay. And then this is just like day 9. Okay. Then you call that mutable. Numbers dot sort. Yep. And then numbers dot iter. And then you would say I dot next. Then you would say I. You would fold. You know what's a parse iter So I think maybe you don't do that. Numbers dot iter dot fold. I want to have a 0, 0. And Okay, and then you would say, well, I don't know. Well, I think my game is ready, so I'm going to call it a day, and then we'll do this one tomorrow. We're almost there. Let's see how we're doing on our stats. Ooh, only 7,888 people have done this one. Leaderboard. Nowhere in the leaderboard for sure. Personal stats. Getting better. Okay. Well, anyways, thank you for watching if you've been, and yeah, cheers. We'll see you tomorrow.